All right, welcome to Mr. Strauss's Chemistry Corner. It's been a while. So please put your cell phones away, put your trays in their upright position, stow all luggage underneath the seat in front of you, and buckle up, okay? In the event of a water landing, a little life vest will drop down in front of you. All right, so you ready? Your homework tonight are numbers 18, 19, and 20, Jackson, in the packet. So 18, 19, and 20, page 54 in the packet. So the packet has got the page numbers, right? So I ran off all of chapter 3. So page 54, 18, 19, and 20. I did write down the answers here so that you can check Lily to see if you did them right. And for number 20 in particular, you need the specific heat of carbon tetrachloride, okay? So I'll give you a moment or two to write down the answers to those 3 problems, as well as the specific heat of carbon tetrachloride, okay? I will take attendance while you are doing that. When you are done, just look up so I know I can move on. All right, so as you're still writing that down, I'm going to write the equation for number 1 from the lab. Now I know we did number 1 together, but it was kind of rushed at the end of class. So I just want to review how to do number 1 so that you are not like completely lost. So for number 1, it asks you to calculate the specific heat of the metal. We're going to do it in 2 steps. So the first step is to write down your equation. So we wrote down the heat gained by the water is equal to the mass of the water. Did everybody get this down? Yeah. I'm gonna actually start this problem higher up, so I don't have to use the other board. Now, if you already have this done, great. You can double check your numbers. The review will be good. So writing your equation is always the first step. Okay, Emerson? Write your equation. If you get stuck and you need help, and I come over by you, and you don't have the equation written, I'm going to say, write the equation. Once you got the equation written, call me back and then I will help you. But I'm not going to help you if there's no equation written down. Okay, that's the first step, write the equation. Second step is to write down all the info you know. Now, we don't know the heat. That's what we're trying to find, right? So that's why I put a question mark there. That's what we're trying to find. The mass of the water. Since we had 100 mils, Ridley, it means that it's 100 grams. And it's not so important that the video stays on me, it's more important that it stays on the board. All right, so that's the mass of the water, the final temperature of the water. So in my group, the final temperature of the water was 26. The initial temperature of the water was 24.3. And the specific heat of water, 4.184. So you should have all your information. Now, why the heck do we do that? I cannot tell you how many times people plug the numbers in the wrong spots. But if you write it down, not only will you plug the numbers in the right spots, you'll get the right answer. And there are a lot of times, Taylor, people are like, I don't even know what I'm trying to find. Well, what are you trying to find? The heat, okay? The Q. So then we plug the numbers in. That's step 3. So Q is mass of water times the final minus the initial times the specific heat. And then I get this. Whoops, I probably should have showed you this. Do the subtraction first. Sorry. So that's 100 times can I even do math? So you got to do that subtraction first. Now we multiply our 3 numbers together. Okay? So you got to do the subtraction first, okay, Lauren? Then multiply the 3 numbers together. Energy is always measured in joules.
Yeah, that's the second one.
Now, how many sig figs do we use?
3.
Well, I got 3 sig figs here, 2 sig figs there, 4 sig figs there. So I know yesterday I said 3, I was kind of fudging it a little bit, I'm sorry, but since I'm gonna put this online, I probably should do it correctly. That's got 2 sig figs. So with multiplication, we should have 2 sig figs. So this would round to 710 joules with sig figs. Okay. I'm not as strict about the sig figs. What I just want you to get away from is writing down every single digit the calculator shows. Right? I want you thinking about sig figs as you do these problems. Now, where did this, so this is the energy gained by the water, right? Energy just cannot be created. It has to come from somewhere, Mike. So if you're walking down the hallway and you find $20 on the floor, did that $20 just like materialize out of nowhere? No. Where did the $20 come from? Somebody lost it, right? It has to come from somewhere. So like I've always said, if I'm minus $5, that means somebody else has to be plus 5. So if I'm minus, then you are plus, okay? So let's try it the other way. If you're plus 5, what am I? Minus 5. So what we did was we said the water is plus 710. Right? The water is plus 710. So now we're going to do the second step. So I appreciate, for those of you who are like, man, I got this down, Mr. Strauss, I already did it. Great, but I still think this is a good review. So this is the first step. To find the Q of the water. The second step now is we are going to find the specific heat of the metal. So we're going to go ahead and we're going to rewrite our new data. We're going to try to find the specific heat of the metal. The mass of the metal, we have to write that down. So you use your mass. The final temperature of the metal should be the same as the final temperature of the water, right? When two things touch, they have to eventually come to the same temperature. So the final temperature of the water is going to be the same as the final temperature of the metal. But the initial temperature of the metal is going to be much hotter. It should be very close to boiling. 98.6 degrees Celsius. Okay. So we have everything we need to solve for the specific heat of the metal. The only thing that's going to be a little bit different here is the water's gaining, so it's positive, right, Kayla? The metal is losing, so I would say negative 710. So I don't plug in a positive value, I plug in a negative because the metal is losing it. Then I can plug in my numbers. And then it becomes an algebra problem. So you write your equation, write down your info, then you plug it in. Then we do the algebra. So the first thing we got to do is our subtraction. negative 710. After I do my subtraction, okay. Multiply these two numbers together. So I took the 72.6 times that to get that, and now I'm going to divide. A negative divided by a negative, that's going to give me a positive number. And because now I've got two sig figs here, my answer is going to be rounded to 2 sig figs. So here's my specific heat of the metal, 0.14 joules per gram degrees Celsius. So raise your hand if you need some help, and I'll come over and check your data, okay? Or check your math. So I'm just gonna you can just keep it on the board there. I'm just gonna run around and check, make sure.
Right.
Where's your answer?
Yeah, you did a lot of extra steps.
Okay, there's your
You have
answer.
this down, this is the
That's
water,
okay. We can-
like the temp of the water. You have the temp of the water, and you have the metal. Yep. So you have the important things. And then so we have to, that's specific heat of metal. And so then we have to do the math for that one right here. This times this, and we get negative 750 for rounding. Or no, sorry, we already have that, we get this number.
So it seems like everybody's doing it right. So why don't you go ahead and do number 2, okay? And do your calculation for number 2, and I'll come by and I'll check to make sure that you're doing number 2 right.
So we're pretty much, we want to get rid of this number so that we get the specific heat of metal. So we're dividing, cancel it out, and then we're dividing this. And so then this number equals specific heat.
Just let it run, okay?
Okay,
Even though there's nothing going on.
fair enough.
Okay, so we rounded this, I know we didn't do that yesterday, so now it's 750, not 753.
And if you want to go ahead and do number 3 and average your 2 trials, you can do that.
Right.
Add the 2 numbers together, divide by 2. So if you're already on to number 3, go ahead and do number 3. But that's okay if you're not there yet.
Yeah, and then you do two. Because the 8 would round to 5, 5 rounds up.
Do it and see if we get there. Oh, that's your answer. Oh, that's your answer. Okay. Then, just
So that number's on the top and the bottom?
Yeah, because we want to cancel it out.
you would say 1,000.
So we just
But
get
that's
specific
from-
heat of metal.
If you're able to remember
We
that.
divide them, we get lots of other numbers, but we just want two sig figs, 0.6. And then what he has in that box there is 0.16 joules over gram Celsius.
When we have all the zeros?
No, because we're just doing, we're sig figs.
Yeah, but it doesn't, if it's to the right of a number, of a decimal without the number in front of it.
Yeah, those are sig figs, but we only need two.
Well, I thought they are 6. So like you could put on the zeros.
They're not zeros.
Oh, wait, never mind.
And so it's just points. Yeah.
I think I did everything. You did all the math right, that's good. Okay. It could be just maybe on the first one, or on the second one.
think we crushed it.
You check mine.
Okay. Now number 2 is the exact same thing with trial 2. We got very similar numbers. So we plug it in. Yeah, so plug it in with the first equation that he has after number 1, plug in those numbers from trial 2. No.
Wait, there's.
What's, okay, so I'm confused. What's the Q?
That's the,
I'm not sure what it is.
that's the energy in the water, I think.
Average them together.
I don't know. I have no idea what it is. Exactly.
Yeah.
Is that CPMT or is that? Yeah.
So then we had 8 last time, and this time we have 26.5.
Yeah.
Oh, RQH shows there.
No, you put it down, right? Because, the mouse.
Where was it? 24, no, 24.06.
For division, is it?
07. I thought it was 7.
I wrote
Lily.
Was that here?
07.
No, I have one.
Oh wait, did you measure it?
Yeah, I want to see it.
Who was the one that measured it? It shouldn't really change.
Yeah. She did she did not like it. I might have deleted it.
Lauren, this is what I got for
Is
this
this
last
last number always the
So it rounds up to the four.
Because that's the temperature of the.
Yeah, that's gonna be the same.
But our time for
Yeah.
Okay, now we do that.
Why'd you save that? I don't know. I have that. Ours was like, ours was. Oh, no. Like, raw. The thing is, I wasn't here looking.
Once you've got, number 3 done, look up so that I know we can move on to number 4. Okay. That's fine.
Wait, Lauren, how do you add
Start, what's the for again?
You add both of them and then divide by 2.
Eat up water?
Into the water.
Because I know the H is water.
Yeah, the specific.
Q stands for heat, so your heat gained by the water.
Okay.
What you times them, add them, and then divide them by 2.
That's what I got.
I don't
Is
think it
it-
was 0.07. I think it was 0.7. I think it was. I think it was
Divide by
0.7.
two?
Wait, what'd you do?
Wait, Lauren, I got, that's what I got.
I think you might have taken the time extra.
Okay, this plus this, divide by 2.
You did do a little bit more accurate. So it might be a little bit different.
You just got two different answers. Add them first before you divide.
Do 0.0525 plus 0.9.
Yeah, you just said really good that.
Yeah, that's what I got. So the point.
Where is this?
Okay, yes, 24.7.
About a minute or two more, and then we're gonna calculate percent error.
That gets us a more accurate answer to his and everyone else's.
And then make sure you get a unit. No, it's grams.
Okay, so we get 700.
That does not make sense. Hey, wait, what are you doing today?
So then you divide. And then you're yeah, you don't put the
So what's the actual subtraction to that number?
One height. So we'll need 2 sig
So then we multiply 100 by 2.8.
and 4.184.
Are you able to get me over here, Kiera, or no?
Multiplying all three of those.
Does everything have the?
All right,
Yes.
or should I just
Yes,
go
we're
over
gonna
there?
get this.
If you could go over here, that'd be fine.
So,
And then make sure you have the negative.
number three, you take the average. So I know some of you are still finishing up your calculation, but my group got 0.31 and it got 0.14. Now, in a perfect world, these two numbers should be closer together. If they're not, that's okay. It would be nice if we could have done 10 trials, but that would take too long. So we have 2 trials, so we're gonna add them together, divide by 2. Two, because we only had 2 trials. That is your experimental. That's what we got in the experiment. Okay? So, this is what we got in the experiment. Now, what did you really get? What is the theoretical? That you have to be told by me. So there's a group of metals there in number 4 to choose from. Aluminum, lead, tungsten, brass, gold, zinc, copper, tin, bronze. Do you think I put gold out there? No. Probably not. So I look at my list and I say, okay, 0.23, that's probably the closest to tin, right? So I'm gonna guess tin, but actually you don't have to guess because I'm not gonna literally tell you what you had. But you take your theoretical, and for number 5, you're gonna calculate your percent error, which is the experimental minus the theoretical, divided by the theoretical, absolute value times 100%. So your experimental is what you got in the experiment, or in other words, the answer from number 3. Okay, your experimental. I'm going to come by and I'm going to give you the actual value. So that you can complete the rest of the process. Now, what number did you guys have? Number 4? Let me just figure out what number 4 was, and I'll tell you.
So for maybe it's supposed to be plus, if it's already negative. We're gonna
So you guys, in fact, did have
Yeah,
10.
okay.
So 10, the theoretical of 10 is 0.2274. So that would be the number I would use here, 0.2274. That's the theoretical. And then you divide by the theoretical. Okay?
We all had 10?
No, no, you did not all have 10. Just that group had 10. I'm gonna come by and tell you what your group had. Because there were 15 different metals, remember? Maybe you had gold.
I'm gonna assume that we.
Maybe you had silver. So, at least you guys can start doing your percent error.
I'm gonna assume that. What number 12?
I will come by.
We got the same answer.
Yeah, we got for both of our trials.
That's good.
That's good?
Yep.
Okay.
So, what number do you have?
11.
11?
Okay. All right.
That's the most important question. Like.
You had 10.
10, okay, thanks.
Everyone wrote down their thing they were. Wrote one, tell me. It was Sharpie on the metal. And it had a number on it. Yeah, it was 6.
Our average was what we got, 0.16.
Oh, business is the average around.
Right one. Wait, right one.
We didn't do terrible. I don't think we did terrible. I don't, yeah, it was written on the, I don't remember the number.
He's telling everybody.
You
He's
had
telling everybody that you know.
Pisses me off.
I know. Wait, let's go look back. Alright, then we had 10.
Hey.
Okay, what number do you have? 13?
Our estimate minus that divided by that.
We're doing exactly what he did, because we actually.
Yeah, but with our 0.16.
If I had to guess, I'm gonna like guess.
Michael is dropping glasses. You guys.
So,
I have 12.
Yeah, zinc.
So far off.
You saw, zinc? No. 12?
we're saying
Wait,
negative
13.
negative
13 was zinc?
0.0674 here. Yeah.
Round one just like
I gotta go see it.
Let's go with 5. Divide us by 2274.
You're not gonna figure it out by looking at it.
Times 100%.
I didn't know what that number meant. I probably should have. I looked at it and I was going to say something. I'm like,
Is that about 12?
yeah, I'm like,
You wanna know about 12?
I was 12.
13 I already told you, right?
We got a negative 29%.
There's no.
What's your percent?
Alright, what's that sound or number?
We messed up. Max Jones spilled all the stuff.
No, I think I just did the math wrong.
Say it one more
Did the math wrong.
What number did you say? You said it was chunky?
Oh, yeah, what is
Anybody else?
I can't get our percent error. It gave me negative 29. Does that mean? Oh, okay.
Mr. Strauss, what was
29%.
Pretty sure it was zinc. Tungsten.
We have zinc.
Oh, it was tungsten then, I think.
Divided by.
Wait, if it's tungsten, then we're not that far off.
That's right.
Yeah.
We just have to have a good conclusion. Explain what we error.
Number 2 is zinc.
See? Wait, you said you guys have green?
Yeah.
We could mess up our play place.
Anybody else need to know theirs?
We messed up.
Once you are done, then you can start like working on the questions in your summary.
It's 73%.
All right.
No.
So you can do your analysis questions,
Would you know?
write your summary.
How do you do that? As specific heat, get too hot.
What?
Heat get too hot and die. I didn't know what to write.
100% of the time.
Or at a specific heat, you're like,
Yes, I do.
water.
Alright, we were in, we did.
Sorry, it's an area. Wait, 5%. So 39.0.
That's really good. Mine is 73.2% wrong.
Bro, what? 73%?
How does it even
I don't feel so bad anymore.
Yeah. What we got based off our student math with the actual, like, based off what scientists have done. Wait, what is this?
I didn't know what our error was.
Because it's just based off how we asked.
Although it was always the same percent error.
Not always the same error.
Oh, but that was our number.
Yeah, yeah.
So this, so if you did, if we did zinc.
I'm gonna go look at my next system.
What? You're gonna give me your notes.
That's how I got to.
What is it? Let me
We
see.
just have to write special things.
When you're done, you can put it under the tissue box back here.
What does that mean?
Okay?
This is what I got.
So it's only 9%, it's only 9%. It's not negative, it's absolute value.
Okay.
9%.
Number 1, we have to state our results in both words and numbers.
Mr. Strauss,
State errors.
And we can get it wrong.
Are we supposed to?
I'll consider these at least 2 of them, and then we have to, how we can fix those things.
Oh, I know I did wrong.
When we're talking about our errors, we cannot mention sig figs as a mistake. We cannot use errors or calculations or difference So basically like errors like when we dumped the water in there, some of it spilled.
That's an error.
No, calculation.
You're gonna have to have colder water than colder than water.
Okay, we'll say that though.
Like that?
So if we had a 29% error, our specific heat of metal was.
I think we can hit stop now.